All right, so now we want to look at how we find the solution to a game. So let's say that we have this game here, whatever the players might actually be doing to get these outcomes doesn't matter. We just want to look at, given that they have these payoffs, what should they do? Okay, and so to solve this game, we're going to use the dominance principle from decision theory. So here's our table, and we're just looking at the payoffs for player one. We'll just focus on those for the moment. So you may recall that when we try to determine if one of player one's strategies dominates any of the others, we have to take them two at a time, a pair at a time. So we'll take R1 and R2, and then we want to know if C1 happens, which strategy is better, and so that would be R2. If C2 happens, which strategy is better, that would be R1. Okay, so neither one of these strategies is going to dominate the other. If C3 happens, then R2 is better, and if C4 happens, then R1 is better. Okay, so neither is better than the other, neither dominates the other. Between R1 and R3, if C1 happens, R3 is better. If C2 happens, they're equally good. If C3 happens, then R1 is better. And if C4 happens, then again, R1 is better. But neither strategy dominates the other. And then between R2 and R3, if C1 happens, R2 is better. If C2 happens, then R3 is better. If C3 happens, R2 is better. And if C4 happens, R2 is also better. Okay, but again, neither one of these strategies dominates the other. So okay, none of player one's strategies dominate any of the others. Okay, so that was familiar. That should have been familiar. Now, when we're doing the dominance principle for player two, we just have to make sure that we are looking at the rows, not the columns. So when I was just considering whether either R2 or R3 dominated the other, I was looking at comparing them in columns. Now I want to compare the outcomes in rows. So we'll start with C1 and C2. So if R1 happens, they're the same. If R2 happens, C2 is better. And if R3 happens, C2 is again better. Okay, so C2 dominates C1. That means that player 2 is never going to play C1 as long as he or she has the option to play C2. Okay, player 2 will never play C1, and importantly, player 1 knows that. None of this information is hidden, so in effect, this is the game that we are dealing with. Everything's the same except strategy C1 has been removed. Okay, so now we want to do the same thing, see if any of player one's strategies dominate any others. So we'll start with R1 and R2. So if C2 happens, R1 is better. If C3 happens, R2 is better. And if C4 happens, R1 is better. Okay, so neither one of those dominates the other. Now between R1 and R3, if C2 happens, they're the same. If C3 happens, R1 is better. And if C4 happens, R1 is better. Okay, so now we see that R1 dominates R3. Okay, so we don't want R3. And both player 1 and player 2 know that. So now, in effect, this is the table. Okay, so we know that neither R1 nor R2 dominates the other. So let's look at what's going on with player 2. So we'll take C2 and C3, -2, -4. -2 is better. And if R2 happens, -1 and -5. So again, C2 is better. So C2 dominates C3. So we don't want C3. Both players know that. So now this is our table. Okay, let's look at R1 and R2. So if C2 happens, R1 is better. If C4 happens, R1 is better. Okay, so R1 dominates R2. So that means, in effect, this is the table. Okay, so we know that R1 is going to happen. So for player 2, we're comparing -2 and -5. -2 is better. So C2 dominates C4, and we're left with this. So this is the solution to our game. This strategy pair, R1 and C2. Okay, here's one more example. So let's start with player 1. If we're looking at R1 and R2, and C1 happens, then they're the same. If C2 happens, R1 is better. If C3 happens, R1 is better. But if C4 happens, R2 is better. Okay, so neither dominates the other. R1 and R3, 0, -4. R1 is better. 1, -5. R1 is better. 1, -7. R1 is better. But for C4, 3, and 8, 8 is better. Okay, so neither dominates the other. Okay, between R1 and R4, if C1 happens, R1 is better. If C2 happens, R1 is better. If C3 happens, R1 is better. And if C4 happens, R1 is better. Okay, so R1 dominates R4. Which means we have this. Let's look at player 2. So between C1 and C2, R1 happens. C1 is better. If R2 happens, C2 is better. And if R3 happens, C2 is better. Okay, but neither option dominates the other. C1 and C3. If R1 happens, R1 is better. Excuse me, C1 is better. If R2 happens, C3 is better. And if R3 happens, C3 is better. Okay, so neither dominates the other. C1 and C4. If R1 happens, C1 is better. If R2 happens, C1 is better. And if R3 happens, C1 is better. Okay, C1 dominates C4. So now this is our table. Let's look at player 1 again. So R1 and R2, if we compare those two strategies, if C1 happens, they do the same. If C2 happens, R1 is better. And if C3 happens, R1 is better. Okay, so R1 dominates R2, which means this is our table. Okay, let's look at player 1 strategies again. So if C1 happens, R1 is better. If C2 happens, R1 is better. And if C3 happens, R1 is better. Okay, R1 dominates R3, which means we have this. Okay, so now we know R1 is going to happen. We can also see, so I've been doing these just one at a time, but we can see that in this case, C2 and C3 are exactly the same. So if we compare either 1 to C1, we'll just do C1 and C2. So 0 versus -1, 0 is better. So that means that C1 dominates C2 and C3 is the same. So C1 also dominates C3. Okay, so we just have this. Okay, so the solution and the Nash equilibrium, I'll let you look in the notes to see exactly what that's about. But in any case, the solution is R1, C1. Okay, and then in the next video, I'll go over this.